In our last video, what we did is we solved this problem, and now what we need to do is the review and evaluate steps so that we can check to see is there anything that we can do to improve this. But in order to do that, what we need to do is understand the components so that we understand how they affect our runtime complexity and the maximum amount of space that we use. Okay, let's look at the function. So how do we know what the size of n is dependent on? Well, given our input's a string, and it's not an array of strings or anything like that. So the size of n is going to be the length of our input string. So that's kind of how we know, like, how many operations is it going to take. Okay, so the very first thing we do is pass input string into clean string, and then we reserve space for the return value. So the clean string may be slightly smaller than the input. If we were given a string with like mostly punctuation and 2 or 3 characters in it, it might be a lot smaller, but that's not the average case. So we just kind of think of clean string to be about the same size as our input string, because that's the safest thing for us to imagine. So now we go into this clean string here, and if we look at dirty string is going to be the same general size as our input string. And then what we do is, this is actually a loop, right? Because what this function does is it goes over every letter in the string, and it changes its value from uppercase to lowercase, or leaves it alone. So this is like a loop. It can only do things character by character. That's how computers operate. So any of these string operations, they seem like one operation, but they're really loops over the whole string. Okay, so then we reserve space for another string that's going to be, again, approximately the same size as our input string. A few characters less, but we can't predict how many, so we have to assume no characters less for the purposes of understanding how much size this could take up. Now, it's never going to be larger than the input string. We're never going to add characters to it in this function. So we know that it is at max n. We've already created kind of another space for it, so that's sort of 2 spaces. So this is like 2n. But in terms of complexity, it's really just n. Okay, if element is alpha, that's like another check. But we're only checking one element, right? One piece of input, and so we're not looping over a whole bunch of stuff. So this is one step, but this for loop, it's a whole other set of steps. Now clean string plus element, that's what creates sort of this thing. So what we've really got is two parts where we go over pretty much the whole string. This, though it goes over the string a couple of times, we call this O of n because the relationship between the number of steps that the computer will have to take and the input is still linear. It doesn't grow by the input by any way, so it's not n times n, and it doesn't stabilize over time, right, to a maximum. So it's not like log or like a limit, right? So this is definitely just O of n here to run through this. In terms of space, the maximum amount of space that we're going to take up is like 2x, right? Or 3x, really. We can remove some of that by taking this operation and putting it here. So rather than dealing with lowercase string, we just deal with dirty string, and we lowercase it within the step. Now, that's less, it's less steps, but it's not really not linear, right? And so we haven't like improved its linearity, we've just improved the number of steps. Once this is over, though, all of the memory within this disappears. So you don't add the memory that this takes to the memory that maybe the rest of the function might take up, right? Because once this function is done, it's deallocated, and so all the memory is deallocated and you don't have to count it. So we have our input string and we have clean string, which is assumed to be the same size as input string. So that's 2x memory. Now, here in this line, this again looks like a single operation, but it is not a single operation because a string, in order to do string comparison, a string is actually a sequence of characters. It's basically an array. So what we have to do is essentially loop over the string. Python does this for you. It sort of obscures that is happening, but you have to keep in mind when you're reviewing code that is happening, right? Doing a string comparison is a loop over n. So what we do here is we actually create space for another variable. Even though we never really store it in a variable and hold on to it, we still have to create space to hold on to the reversed string. So this is 3x in terms of the space. It takes 3 times the input. And we have like the loop here, O of n loop, and then another like O of n. So it's sort of, I think we had 3x up here, and so this is like 4x, but that is again still linear, right? Clean string, like each character of clean string is not compared to like every other character or anything. It's just compared 1 to 1. And so this is a linear function. So for this we have O of n with a max of like 4x space, kind of all told. So yeah, that's how you evaluate this. So we made that little change here, but really, we're not going to get too much better than linear.